What's going on, everybody? Welcome to this live stream on mastering Apache Spark in 2024, your roadmap to success. So in the end of this webinar, we will have a large session of Q&A. So I will try to answer all of your questions as far as I can. You can basically ask me anything. But for now, I would like to talk with you about Apache Spark and how we can learn it in 2024. And I've created a small outline for today's session where that we will use as guidance for the time you have. So first of all, I would like to ask you to tell us where you are from. Some names are familiar. Tito, greetings. Thanks for joining. And on the second part, we will talk about why Spark is actually the most important skill for a data engineer. Some of you may have seen videos from me talking about this before we move on to the Spark Mastery roadmap, which you may have seen in one of my posts or on my YouTube channel as well. But I will go in much more detail here and answer your questions about each of these steps. And then in point 4, we will talk about how can you accelerate your learning before we move on to section 5, where you can ask me anything you would like to know. I will try to answer as much as I can. I've been working with Apache Spark for 8 years as a freelance data engineer. So I have with a strong focus on Spark, so I have quite some knowledge about it. So whatever you're struggling with, just shoot it to me. I'm very interested and try to help as much as I can. So why is Spark the most important skill that one can have as a data engineer, or at least one of the most important skills? Now, in today's modern data platforms, we usually have a 2-tier architecture. We are trending towards a single-tier architecture where we only have a data lake, but usually we have a data lake and a data warehouse. And usually all the source data is ETL'd into the data lake, where we store data in file formats. And then we ETL it again into a data warehouse where it's highly structured and very organized so that we can build BI and reporting use cases using the respective frameworks. And then we have also the entire advanced analytics use cases, which usually require us to have file access directly. So they usually don't access the data warehouse. That's why we are moving more in the direction of data lakes or data lake houses. So there are new technologies where we actually add data management capabilities on a data lake. However, usually we have an architecture like that with most of the organizations. And now if we look at where we can use Spark, it's actually bubbling up everywhere here on this chart. So and that's why it's such an important tool, I would argue. Basically, we use it to implement ETL processes, to clean data, to pre-process data, to get it in a highly structured form, even into the data warehouse. We could also use Spark to implement machine learning use cases or even pre-process data in large scale for machine learning use cases. And also we can implement some application logic directly within Spark. So there are definitely applications, so business rules and logic which are implemented in Spark. And therefore, it's quite essential for a data engineer whose job is it in general to provide data to all the applications who would like to use it within an organization. So therefore, it is part of most job descriptions you might see for a data engineer. And usually companies searching for a data engineer require the applicant to have extensive skills in Spark. And that's what brings us here in the first place. On the other hand, it's quite a complex technology, and it may be frustrating and overwhelming trying to learn it because there are actually so many facets to it and so many things to consider. There are many, many resources, and therefore it may not be as straightforward as we would wish it to be. And I basically experienced that talking to many people trying to learn Spark, that most are struggling with the same problem. which is basically to figure out a way which makes sense to learn it actually. So we would like to have a detailed roadmap. So if you just imagined you had a step-by-step guide which you could follow, so you would have some resources that you would read one by another, and you have assignments in between, so you can set up your project and just follow the plan step by step. It would be much less overwhelming than as if you had no plan at all. And therefore, I created this roadmap for your guidance. And here I would like to walk through the 6 steps I came up with. And whenever you have a question, please basically send it to the chat so that I can answer them right away. Also, you will get the chance to ask questions later on. So on this roadmap, in part 1, we are trying to learn the Spark SQL API, which is the API or the component of Spark which is vastly used within corporations for data engineering. And here in part 1, we would like to really get familiar with the API itself. So here we basically learn to implement applications and use cases. And within this part 1, I would put the steps for that you set up your development setup. So you have to choose how you would like to learn Spark. I always recommend to use an IDE and your local laptop, because as you are aspiring to become professional in software engineering, so Spark engineering, I always recommend to use an IDE, which provides us many, many features which are very helpful to become fast in the end to write code. And also it's beneficial to be able to set up your setup yourself, because the alternative would be to use a tool like Databricks, for example, which actually sets up everything for you, so all of the dependencies and so on. But I would recommend you to use a local setup with an IDE and set it up yourself. Then you would have to find some example data, because in the end we would like to build a project which you can use and showcase also on applications to future job applications. And I would recommend to go to Kaggle, which provides many data sets which have been cleaned and prepared for use cases like the one we would like to implement. So there are many data sets from many different industries. It doesn't really matter which one you choose to use. However, so whatever industry you're interested in, you can find a data set there, I guess. The only thing you will have to do is to make sense of the data which you are using. So you have to have at least some idea of what all of the data fields mean that you are downloading there. And usually what I do with the students I have, I really try to teach them a highly professional working style, which means they are not allowed to use Google or ChatGPT or anything like that. But all information we collect is actually from the official documentation. So that will inspire a deep understanding of how the API is structured. And later on, you will be much, much faster in developing Spark code if you are not relying on asking questions to Google and copy and pasting code snippets, but rather be able to make sense of the documentation yourself and find the information that is most relevant for you, which will give you a very deep understanding of how the API works. And that's what I mean with explore the documentation. In part 2, we would study the internals. So Spark has has actually one very foundational concept or paradigm which is based upon, which is called MapReduce, even though it adds many abstractions or optimizations on top of it. But in the end, the workload we implement is executed in a MapReduce manner. And therefore, we will understand what this is and some other concepts, for example, how parallelism is achieved and what partitioning is and so on. And we will also study the high-level architecture. And so here we would cover what is a worker, a driver, executor, a master, how are the nodes deployed in a cluster, these things. And also, I would recommend to study the Spark SQL component. So there are happening some optimizations, and there is an automatic optimizer, which will try to optimize your Spark SQL queries that you implement in your application. And if you have no understanding of that, you will have a hard time in part 4, which is basically performance optimizations. So in part 1 and 2, we're actually laying the foundation for part 4, which is performance optimization. So that would be part 2. So I would recommend you to develop a good foundation of the internals or the fundamental principles that Spark is based upon, so that we can move ahead to part 3, which would be real world Spark. And with real world, I mean in a professional project that you may work on in the future, you will have to deploy applications to a cluster rather than running them on your local laptop, as we are doing in part 1 and 2. And therefore, I would also study how to deploy an application, for example, to a cloud provider, for example, AWS. So it's good to have done it a couple of times before you apply for a role with Spark. Also, as we deploy applications to clusters, we will have to figure out how we can deliver configuration and what the essential configuration parameters actually are. And once we have deployed the application on a cluster in a distributed manner, like in a real world setup, we will also need a way to monitor the running application, and that we would cover, or that I would try to study in part 3 as well. So that would be part 3. And these 3 steps already form a very, very strong foundation for part 4, which would be performance optimization. And I like to say that performance optimization is actually, or comes by itself, if you have this very good foundation of parts 1, 2, and 3. Because as we have a good understanding of the application itself, and we have a good understanding of the internals, and we can monitor a running application or even after the fact, we will be able to mitigate most of the performance issues we see in Spark applications. And basically, there exist 5 or a couple of common performance issues that we have to study and be aware of, because these common issues follow basically some basic patterns that we can detect using our monitoring of our application. And once we have detected and identified the pattern, we can actually mitigate these performance bottlenecks by following quite simple approaches. And here in part 4, I would also suggest that you have a look at AQE, which is Adaptive Query Execution, which has been added recently to Spark. It tries to take away some of the performance optimizations we had to do manually originally, but it cannot do it in all cases. But still, we need to have an awareness what's happening. So it's good to have an idea what AQE actually is and how you can detect what has actually happened and what has actually been executed on the cluster. And then I would also suggest to study memory management a little bit, which basically leads to some of the metrics we can find in the monitoring. Moving on to part 5, I would continue with integrating Spark with other technologies. So in real world setups, we have to use different data sources than, for example, a CSV file or Parquet file that we use locally, but rather we have to use other data sources like Kafka or HDFS, S3, a relational database or data warehouse, HBase, whatever. So here we would work with different data sources, how to configure them, how to connect to them, and how we can basically deploy to the cloud, also using other data sources. And then through the forest to part 6, which I call Become Pro. And this is probably the hardest part to do on your own, because I would argue that here the experience plays a major role. So here we're talking about writing high quality code, and the foundation for that would be to define what traits high quality code has. So what makes high quality code, and then also about or study software engineering patterns for Spark. Basically you could do that basically by looking at other projects, by open source projects that someone has done, and look how they are structuring their Spark code, try to reason about why they are doing it in a particular way, why is it better than any other way, a solution you could have chosen, and also to become fast, which means to use your IDE properly, to write tests fast, basically to use some common sense software engineering patterns, which will allow you to write code fast and make changes fast, so that you can later on also change your application, which will result in delivering high quality code very fast. And yeah, here, as I said before, the experience plays a major role. So once you work with Spark for 10 years, for example, you will have that experience. You will have produced some errors that you have fixed yourself and debugged yourself, and therefore you will have a good understanding what's better and what's worse. Or you can try to reach out to someone who has a lot of experience, asking them to teach you how to write high quality code, or what they learned using Spark and so on. So that would be the roadmap which I came up with. And for everybody who has joined recently, I would like to ask you to just comment where you're from, how long you have been using Spark, and what you are interested in learning. Just say hello. Thanks for tuning in, everybody. So that is the roadmap. And let me see what I have forgotten to say. All right. From Nuremberg. Welcome, everyone. The next point on the agenda would be, why should you consider coaching? And I would argue it's the fastest learning opportunity you have, or you may get. That's why I actually chose to offer coaching, so individual one-on-one calls, teaching students how to become pro. And there are good reasons why this actually a very effective way of learning something. So in my opinion, to say from yourself that you are a pro is largely a matter of confidence, and you can only establish this confidence or build up this confidence if you have a good experience working with Spark. So that's why in the coachings I offer, I try to establish a highly professional working style. And that starts with, for example, learning to read the documentation, learning to find valuable or reasonable information or trustable information from official sources, studying the API basically structure very deeply. And as you go along with such a working style, you will build up confidence, because you will be able to fix or research some issues yourself. And I will, for example, give these students assignments which they have to complete on their own, and they know that it's forbidden to use like Google or ChatGPT or Stack Overflow and just copy and paste code snippets, but rather to work themselves into a mode where they know they can they can solve the issue without any external help, and that will build them confidence. And once you are in a code interview or in a basically job interview, for example, you will radiate this confidence that you have established during the learning path you followed. And yeah, basically finding a mentor which has a lot of experience, who can tell you many of the pitfalls or answer all of your questions, so that you put the pieces of the puzzles together and you really understand or generate an understanding or a bigger picture of the technology, will also give you this confidence. Secondly, as opposed to having a video course, a coaching or a regular schedule at least holds you accountable. So usually I do weekly sessions, one call a week. In between we do assignments and we do code reviews and so on. So a regular schedule holds you accountable over a long period of time. And I know how it is to study with a video course, which is usually we are too motivated in the beginning. We just consume the entire video content without doing the actual hands-on practice, which would be our opportunity to learn. Also, we don't get any feedback on our solutions. So a weekly call, or at least having your weekly schedule where you say, okay, 2 days a week, I put aside 1 hour a day to study Spark, is a better approach than doing it for 8 hours in one day. And yeah, also having no binge learning, but rather weekly sessions is much easier to reconcile with a job that you might have. So it's a regular meeting, 1 hour a week. That's easy to basically integrate in your calendar. And the third point I want to mention why, individual coaching or actually one-on-one feedback on your learning is helpful, is that this feedback is your actual learning. So usually if we produce an error in software development, or something doesn't work the way we would have expected to work, is because we have a small misunderstanding about how things are working, and we didn't get it right. So we built our solution slightly off, and therefore it's producing an error. And then we have to look inside and check what was wrong with our understanding. And that happens in feedback as well. So you can learn from your mistakes if you have someone who can explain why the error occurred, or what you were doing wrong, or what you could do better when you make a mistake in your assignment. And also, usually when we are learning something, the video explains something or the teacher explains something, but you still have some open questions, and you have an idea how it actually is, but you never get to ask someone if that's actually the case, what you came up with, what the actual answer may be. So here you have a very so it may be very helpful to have someone who you can shoot a question. And yeah, as it refers to point one, you can gain some experience or some confidence actually by getting your code reviewed from an expert. And once he or she has reviewed your code and told you to do something different and the reason why, or even if he tells you that's exactly how I would do it, you take away a learning from that it was correct. I don't know if you heard the story in a previous interview of mine, but I was learning Spanish for some time, and I studied it on my own. And then I moved to actually I went to a Spanish-speaking country, and I had some issue talking there to people. And the worst thing is, I practiced talking in street conversations, but actually I didn't get any feedback. So there, the goal of the conversation was to exchange information, but not to improve my Spanish. So I didn't know whether I did it correct or I did it wrong. And only once I met with a teacher, a private teacher, over a couple of weeks, I grew my confidence in speaking Spanish, because I knew in this teaching session, he would actually correct me if I did a mistake. So if he didn't correct me, I knew I was getting it right. And if he corrected me, I at least had a learning. And that also increased my confidence quite a lot. And I think I believe that this effect happens with every skill. So it's good to have someone who corrects you and who also tells you if you did something correctly. So that's why I basically provide one-on-one coaching, because I really believe it's the best way of learning. And yeah, these are the reasons for that. Now we have some questions. So Philman wrote or asked whether I would recommend to get familiar with Databricks during the 6 steps program. So as I said in step 1 or in part 1, I would recommend everybody to get started with an IDE. That's simply because you will develop an understanding how to set up the dependencies to Spark. You can use all of the IDE features. Of course, Databricks is a little easier to set up because you can just get started and type your code. However, you will miss the understanding how dependencies are managed and so on. So if you are applying for a professional job, then or if you get a different job where you're working in a different environment, where you are working not with Databricks, but you're deploying your applications yourself, you won't have an understanding how to build a jar with the dependencies, how to deploy it, which dependencies are required. So it's good to develop this understanding right from the beginning. However, if you prefer to use Databricks, I think it's fine as well. You can still learn these other things later on. But also my personal preference, I don't like to code in the browser, actually. As software developers, we are actually editing code all day long. And I make vast use of the IDE's features to become fast, to write code fast. So that's why I personally don't like to code in the browser. However, that's your personal preference. So then we have MySum, who asks, what's your preferred IDE for developing applications? So that's an easy question. I use IntelliJ because I use Scala and Python. PyCharm is fine as well. That's my favorite IDE. I know all of the shortcuts. I have my own key map. I have everything set up as I prefer it. So that's what I use usually. And then which online resources do you regularly consult for learning and staying updated? Yeah, that's a good question. So I follow Databricks, for example, and also on the Spark official documentation, so that's spark.apache.org. They have some news releases there. However, I don't actually follow it too much, to be honest. So I really don't have any great resources for you to stay up to date with the latest trends. Actually, I'm following some accounts on LinkedIn. I would have to find them out. I can't tell from the top of my head, to stay updated there as well. Hope this answered the question. Now I've talked half an hour now. I think we are done with the points I wanted to cover. Now, anybody who has a question, please feel free to post them in the comments so that I can answer them. Also, everybody who has joined recently, I'm very curious where everybody's from. Also, if you like, you can share how you are using Spark or how long you have been learning Spark or what you would like to do with that skill. Just leave it in the comments. A book to follow while doing this path. Hi from Argentina. Good to have you aboard. I cannot really recommend any book, I think. I read one, but that's been some time ago. I think it was called Apache Spark The Definite Guide or something like that. So that was helpful, but from my opinion, most of the books, they have a very strong focus on the hands-on part. And they don't go too much into detail how everything works together. So they usually don't give you the bigger picture how everything works. So there won't be a deep understanding of the concepts of the frameworks. However, to get started and to learn how to use it, maybe books are good, but I would argue there are more helpful resources. In the end, it may be beneficial for everyone to actually take this roadmap and craft your own plan. And what I do when I try to learn something is actually I pick the topic and then I read some blog posts or I read resources I can find. And once I'm done, so while I'm reading, there are many questions are popping up in my head. And I actually just write them down. So I collect all of them. And as I study along, I just try to answer these questions, basically trying to find answers to them with basically deliberate searches about them on Google or something. So usually there is a blog post or something. So basically having your own questions and trying to find them out is a good way of studying, I would say. Do you have any best practices in regards to performance optimizing? From a best practice point of view, so I would say the monitoring you have is very essential. So usually you should be able to see all of the metrics your application is producing, and you should be able to identify. So first of all, I would try to identify if there is any data skew. So if there are any straggler tasks. One task takes 3 minutes, while all the others are taking a couple of seconds. So all of the nodes are waiting for the 3-minute task to complete. And you can find that in a visual manner in the Spark Web UI. So that's the first thing to check. And once you have identified a skewed data set, for example, you will have to go ahead and figure out why, or can we restructure the query in the first place, so the application, so that we don't have to do this operation in the first place? Or is there any other mitigation strategy? However, what I usually advise anybody who's trying to optimize an application's performance is to really know the data well. So actually get some statistics about the distribution of the fields, for example, that you're joining or grouping, so that you have a really good understanding, because usually distributed processing works best if the data is equally or unified distributed, or normally distributed. But that's usually not the case with real-world examples. For example, like one client having 90% of the orders, and then you may easily end up with a skewed data set, or it is a skewed data set, and you may easily end up with a query which actually falls into the trap of the skew. Now, then there's AQE, which is trying to circumvent this already, but that's usually the problem. So what I would advise everybody from a practical point of view is actually to get really familiar with the data you're working on. If you don't have any hard performance problems, just leave it as it is. Only as you see it takes very long and you have straggler tasks and so on, you should really deep dive into these things. Where to find industry level projects? So I guess this question refers to data sets. Probably the size of data sets, if that's correct. I don't know where you can find those. From my experience, to actually gain the knowledge, the confidence, and the skills, and also the experience to call yourself a proficient Spark developer, you really don't have to go to terabytes of data or even gigabytes of data. I would usually stick with a small data set, and also the cleaning and the preparation of data sets, so removing nulls or no values and cleaning up stuff. That's very time consuming because you have to really look into the data and see where you would have to pre-process something. So that's more a requirements analysis, how we would have to pre-process data. But the implementation of that data cleaning and so on and preparation, it's quite simple. So whenever you have a business requirement, okay, we need to clean the data in that way, if you are proficient with the Spark SQL API, you will be able to implement it. So the business rule itself, plus the tests you would need to have some good code, you will be able to implement this very fast. So I wouldn't go for any kind of industry level project to learn Spark, because I also don't think it's necessary. If you are really looking for optimizing performance of a application, it's actually end-to-end projects. But let me finish the sentence. It's also good to have some. You can also generate, for example, a skewed data set and try to fix the performance issue. If you see the straggler task, then try to fix it and simply use synthetic data, which you have generated with a large skew, for example. Okay, but end-to-end projects, yeah, I don't really know where you can find industry level projects. Probably you can come up with your own, simply crawling data. So you can crawl data from Twitter or any other basically online resource, and then maybe have a streaming, basically an event stream of the data, clean that event stream, write it into a data lake if you like, pre-process it with Spark, put it into Lakehouse, and build some machine learning application. I think you can come up with something. There are many data sources which are free to use. You don't have to use like huge amounts of data, but simply building a pipeline may be a good idea. But it's not actually what I'm focusing on too much. I really focus on a deep dive into getting a very good understanding of Spark itself. Okay, Tito asks, what is the success rate of your students after your training? Did one of them give you any feedback, and how they doing their jobs? Yeah, I have very good feedbacks from my students. I also am available to them long term, so they can reach out to me anytime. And basically everyone I have helped who has given me feedback that it has helped a lot. So they actually, what they report actually is the thing that they are feeling confident now. So they have a very good understanding. They are confident to walk the next steps by themselves because they have learned in a proper way how to study it. And even if questions are coming up afterwards, they are mostly able to resolve them themselves. And as I said, they always have basically access to me, so everyone can shoot me a message. Also, every one of you can always shoot me a message too if you have any question. And so from the feedback that I have from the previous students, it has helped them tremendously to improve their Spark skills. Tito's answering a question. That's good. I will continue with Philmon's question. Maybe also an idea how to interpret the DAG visualization in an efficient manner. I know that it can help detect performance issues. Yeah, I feel you. I know how it feels to read this, especially if you have many data sets. Actually, I'm not aware of a more beautiful representation of the duck, actually. I don't know. Usually I go with the command line version of that, but yeah, it's not beautifully formatted. However, there are two formatting options. So you can go to the explain method on a data frame, and you can pass in some mode, I think is the parameter called. And there is actually a simplified or there are two modes for printing the logical plan and the DAG. All right, do we have any more questions? Whenever anybody likes to get some feedback or has a question about Apache Spark, please feel free to reach out to me anytime on LinkedIn. I'm happy to help and ask questions and answer questions. So if you are interested in doing a coaching, I have actually set up a product for this, which you can find at academy.philipp-bonenberg.de. And some things are explained here again. There's one product, which is the individual life coaching, Apache Spark, the effective developer. You can participate in any language, so Scala, Python, or Java, even though I don't recommend Java to anyone learning Spark. So it's basically language agnostic, and you don't have to have extensive skills in any of these languages. And we are going to cover the roadmap I've shown you, and we will figure out your individual learning journey. And we will assess your goals in the beginning so that we can find a journey which is most beneficial for you and a goal which is reasonable, which we can accomplish in 12 weeks. Because actually, this is a 12-week program where we are going to have a session every week. And usually in the week, I give you theoretical input or answer all of the questions you have. And I will also, from time to time, do a code live demo so that you can see how to do things. And in between the sessions, I hand out assignments individual to your current skill level. And in the next week's session, I will review the code that you produce during the assignment. And whatever question you have, I will try to answer them, or I will answer them in our coaching sessions. So if you're interested in that, go to academy.philipp-bonenberg.de and you will find the coaching. All right. So if no one else has a question, we can call this a day earlier. at least in my case, and everyone who is in my time zone. It's interesting because I cannot see how many people are actually watching or if it's no one anymore. So if anybody has a question, now is the time to ask. What would be, I have a question for you actually. What would be what would be a topic of your interest which we could talk about next time? Is there anything in particular which you are struggling with? Maybe we can do a call on that. It could be also a live demo of me building something. That would be interesting as well. What is something you're struggling with, or what would you like to see? No opinions there. All right, so if there's nothing coming up, I thank all of you for joining here. I hope you could take away something here. And yeah, as I said, whenever you have a question, reach out to me. Otherwise, let's call it a day. And I wish all of you a pleasant day. And yeah, see you next time. Maybe in a live stream as well. Otherwise, keep me posted. Thanks for tuning in.